Hello, let's continue our Sudoku adventure with Successor by Emphyrio. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these arrows in the grid. They're called successor arrows. So a digit n in a cell with an arrow means that the digit n plus 1 is n cells away in the direction pointed by the arrow. So the example given is if row 1, column 1 is a 3, then we count 3 away, 1, 2, 3, and this must be a 4, which is 3 plus 1, right? So a 3 here would put a 4 here. Let's do another example. A 2 here would put a 3 here, because we count 2 away, and then we put the digit 1 bigger next to it, or in that cell. And that's it. Those are all the rules. Not all the arrows are necessarily given, so you don't have to watch out for like, oh, I put a 3 here, which means I can't, put a 4 right there, because then there would be an arrow that, no, you don't have to worry about any of that. It's just positive on these arrows only. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So how do we get started? You can't put 6 on any arrow. Maybe that's a place to start, because even here, a 6 here, we count 1, 2, 3, 4, 5, and we put a 7 off the grid. So there's 2 reasons that we can't do it, because there is no n plus 1. Also, yeah, I was going to think about 1s as well, but I'm not sure if 1s are as interesting. 6s can be pointed at by 5s, but okay, so the only way a 5 goes on an arrow is if it's on the outer border, and only if you can put a 6 completely across the row or column. So like this can't be a 5, because if this was a 5, we count 1, 2, 3, 4, 5. We put a 6 here, and then that would break this arrow. So 5 can't go in these cells. 5 or 6 can't go in these cells. So these are from 1, 2, 3, 4 only. And then this can't be can this be 4? This could be 4. So this is also 1, 2, 3, 4. This could be 5 with a 6 here, but this can't be 5. So this is from 1, 2, 3, 4. This is non-6. Okay, this one is a 1 or a 2, just because it can only go that far. Here we go. We get our first digit. This one's a 1. I don't know why it took me so long to find that. So this is a 1, which puts a 2 there. That's a 2, which puts a 3 there. So that's not 3. This isn't 1 or a 2. So there is either a 4 here or a 5 here, and I don't know how to pencil that. But there's a 4 involved, right? Either the 3 puts a 4 there, or this is a 4. Either way, this is not a 4. So this is either, and this can't be a 2, so that's not a 1. So there's either a 3 here or a 4. So 3 is always involved in this cell, because either this is a 2 putting a 3 there, or this is a 3. Either way, that's a 4, which does put a 5 there, which does put a 6 there. Nice. 1 would point at 2 here. 2 would point at 3 here, but that's not allowed. 4 would point at 5, which is not allowed, so that's a 1. This is a 2-4 pair. Okay, can we do more with this? Wasn't 3 always involved in this one? How did I not clear it from there? So if this is a 3, that's not a 3. Oh no, 4 is always involved in this one, sorry. So this is a 3, that's a 4. And it can't be, because the 4 was placed there. So that's a 4, placing a 5 there. This is 3, 5, 6. The 5 is placed. The 3, 6 makes that a 2, which makes that a 3. Sorry, not 1, 3. Went backwards. That's a 6. Nope. That's a 1. Okay, 1 in this box goes here, because of these 2 1s looking in. This is a 6. This is 2, 3, 4. Not sure if I can do anything with that. We know one of them's a 3, but that's okay. Oh, how about this pair? This is the 3, 6 as well. So that's a 6, that's a 3. I have all the arrows filled. Did I not do them? The 1 puts a 2 there. There we go. I missed that arrow. Could have done this puzzle a lot faster, but that's okay. 1, 2, 5. That's a 5. That's a 1. That's a 2. I think we're finishing now with just Sudoku. This column needs a... Nope, I was wrong again. This column needs a 4. This column needs a 3 and a 5. That goes like that. This column needs a 1 and a 6. This row needs a 4 and a 5. Gets all those. This row needs a 2 and a 6. And we're done. Nice. Didn't take too long. Could have been faster if I'd noticed this right away, but honestly, it was nice thinking about generically how the arrows had to work, and I think that sped things up later. I really liked the logic of a 4 was always involved in this arrow, and a 3 was always involved in this arrow. That felt really important. So yeah, let me know how you did on this. This was a cool puzzle, Emphyrio. Neat idea. I hadn't seen it before. I'm not sure if it was Emphyrio's idea or not, but yeah, I liked it. I hadn't seen this constraint before. And of course, if you enjoyed this content, then why not leave a like, subscribe, and a kind comment below.